Hey guys, it's nice to see that you came back after surviving part one. I realized I realized I sounded kind of quiet for the first part, so this time I'll try to sound louder. In this part, we're gonna be learning how to make a scrolling background and put it on the screen. So back to our very first program, we're gonna need to make a few changes. First off, we're using high-res mode here, and there's no background. So going back to this program, let's copy it over into our very second program. So back to this. The first change we're going to need to make is to our this and add a do background. And our three tasks are to initialize background, scroll the background, and in the future render our level. The way we go about rendering levels will change from person to person. I have a way that I like to do it, but that doesn't mean that you will like to do it or that somebody else will like to do it. Maybe you will, maybe you won't. But in the future, I'll show you how I handled it for The Legend of Naomi. Um, so back to our program. The first thing we need to do is change this to from 0 to 5. You'll notice that our shape here has disappeared, and that's okay. Um, Also, we're gonna want to make sure that our sprite is smaller because we're gonna be rendering a full size 32 character wide background here. Um I'm also gonna be including the Legend of Naomi's graphics for this one too, but do know that any character set would work. Um I'm also gonna be switching to low res mode, and one of the main things is that oops, um we're gonna be changing colors around a bit. So back to Legend of Naomi, um I had this convenient little color set. And we're going to be using these colors because we're going to be using the Legend of Naomi's um tile tile set here. So it's still nothing on the screen yet. So let's initialize it. Remember, since we're gonna have to go back to the way we did that hard-coded sprite which couldn't move in part one. It could move horizontally, but not vertically, and that's fine. We're just gonna horizontally scroll. We're not gonna vertically scroll, just horizontally. Vertical scrolling is much more difficult because you need to change DLL shapes in real time. In fact, not even I've ever done this before in a game because I've never found a need for vertical scrolling. But we'll get to that eventually. This is just how to put a background on the screen. The other thing we're going to need is a background. So, and I messed this up. It's actually 284 bytes, not 768 bytes. That's more than we need. So, going back here, you can just follow along as I do this. So now, we have one we have one level of our background. And then we need to copy it for every zone. Again, just follow along as I do this. And feel free to skip ahead if you want to see the background working. And so, there it is. If it was done right, sometimes it's good to check if you did it right. And if you did it right, your DMA pattern should look like this. What you will notice, though, is that this is not right. This isn't right. Why does it look like that? And that's because earlier up here, remember, our tile map only is using it only defines the lower byte of of the memory address. So remember, 1 byte is 8 bits, but we have a 16-bit memory address here, so 64 kilobytes. So going back to our second program, we need to change, but and remember, we defined our graphics, our background graphics would be at hex 8000 to hex 8FFF. That's just 4 kilobytes. And that might sound small, but remember, an entire Atari 2600 program would fit in 4 kilobytes. It might even fit in 2 kilobytes. It might even fit in 1 kilobyte. It's very small compared to our big, beefy Atari 7800 programs. So, we need to change our char base value from hex A0 to hex 80. And now all that junk goes away. More importantly though, we need to change one other thing. And that is, well, also, in case you didn't, you'll notice how the sprite gets smaller when I press this button. That's because we're using way too much DMA here. For a 32 character wide background, we really can't have that big of a sprite. Now, in later programs, you'll find out ways like to change it to 21 characters wide and save a lot of DMA there, and other tips and tricks to make your program more efficient with DMA usage. But In this case, we're just trying to do something simple, something basic. Um, pun not intended. Um, but so back to our program, what we're gonna want to do is put some graphics there. Since now we have our tile map in effect, so we can go back here and do something like this. And also, let's move our sprite out of the way. Go back up to the start. Now it's out of the way. Actually, we might want to move it down a bit. Yeah, that's better. So go back down here and let's make a little something to display here. So what you'll notice is that this is the Legend of Naomi background graphics. But wait a minute, you say. That's not right. Why is it all glitchy like that? Well, we're using something called 2 byte wide 2 byte wide characters. You can define 2 byte wide by setting this bit to 1 or 1 byte wide by setting this to 0. Now, if you set it to 1 byte wide, a lot of our DMA disappears, and also we can have this big massive sprite. But it's not big enough to fill the screen. So, I mean, obviously this isn't the whole thing, but even if it was, it's still not big enough to fill the screen. So, we're gonna use 2 byte wide. This will double the size of our characters. But what do I mean by 2 byte wide? So remember, 1 bit is 8 bytes. I'm sorry, 1 byte is 8 bits, and each pixel here is 2 bits, right? So 2 bits can be 00, 01, 10, or 11. And the way this works is by having 4 different colors you can select between, which give us our four different colors here. And I'll show you how important that is to be careful with your color choices and why later we'll learn how to do an advanced sprite background. And also, but here's the deal. Since only half of our pointer comes from the background data, the other half will come from, well, half of it comes from the tile map, and the other half comes from Charbase. We need to actually do this. And then we need to do this as well. And now you can see the whole 128 characters that Legend of Naomi was made up of. Now, granted, many of these aren't in the correct colors, but you still got the idea. This is the entire graphics for the background in Legend of Naomi. Um, you can even see the Eterno 2025 press fire, and the only thing what you don't see is the thank you to Propane 13 because he helped me get this game signed so it would work on a real 7800 without the use of a flash card. Um, but to show you how limited this type of background is, let me show you a level out of Legend of Naomi. So I have the level select enabled here, which you can see that it's Aqua Beach. As you can see here, no more than 4 colors per 16 pixel high cell. Um, and this looks fine, right? Well, except for here. You can see this green area, which was supposed to be like a tan color, like a sand color, just like the rest of the tree is. But I thought this didn't look very bad, so I went ahead with it. As you can see, there's shorter trees as well, and those don't have that same look to it. But if we go into Retropolis here, we have this green bush, this road here, the stars up here, this gray area, and of course the building itself. This looks fine, right? All this looks fine. But if we go over here, um, to the second area, look at all these X's. These show up earlier in the game too, and I'll show you that because they all look the same over there, but over here, not the case. We've got radioactive color stuff here. Um, gray, yellow, brown, white. It's not very consistent, and you can see like the color changing. Now, if you really want to skirt around that, what you could do is you could do something like change the colors mid level, which would allow you to to have more color without having to make it look that bad. But to give you a more easy way to see the color changing, going to the end of this level, like do you see that? These color changing? This is all the same tile, but the the Maria is displaying it as different. But anyways, back to our program. The final thing we would want to do is scroll. So we can scroll pretty simply by decrementing this scroll value by doing dec scroll, and suddenly it's moving. And as you can see, my sprite here is a high color sprite, so 160B sprite, versus my graphics up here is a low color, aka 160A object. Um, and one more thing you can do is by having something like this, where you can have a table. If you want to change your graphics on the fly, remember, stop to think for a sec. This whole thing is 20 characters wide. So if I go back to start, if I go back to the start where before it was scrolling, this whole thing is 20 characters wide. So 0, 1, 2, 3, 4, all the way to 19. So by adding 20 to scroll, so going back to deck scroll, obviously you need to change it a bit. So like that. Now we have our now we could have something updating in real time. So I'm moving our background loop up a bit. Now we can update our background in real time. So for example, So now we have our background here, and we can change it on the fly. And of course, we can do the full 12 rows. And by the way, you are not limited to 12 rows either. You can make it taller or shorter. Like, if you want to, you can make this whole thing taller or shorter. Like, you don't have to be limited to just using, you don't have to be limited to just using, what is shown here. You can make it taller or shorter. That's the nice thing about the Atari graphics system, is you can modify it. But anyways, we've successfully put our background on the screen, and we've modified our graphics, building our, well, level. We can change it later, but for now, this is quite nice. Anyways, that's it for part 2.